This lesson is on secants, tangents, and angle measures. First, we want to define a secant and a tangent. A secant intersects the circle at 2 points, as you can see on our example here, and a tangent intersects the circle at only 1 point, as you can see on our other example. Theorem 1 states that if two secants intersect in the interior of a circle, then the measure of an angle formed is 1/2 the sum of the measure of the arcs intercepted by the angle and its vertical angle. So here in our example, if we want the measurement of this angle formed by our two secant lines, we take 1/2 of AC plus BD. In our example, we want to find the measurement of angle 1. Our equation is 1/2 the arc formed by your angle and the arc behind your angle. So we have 1/2 BC plus AD. Plug in our values and add the 2 degrees together, and we get that the measurement is equal to 25 degrees. Theorem 2. If a secant and tangent intersect at a point of tangency, then the measure of each angle formed is 1/2 the measure of the intercepted arc. So we have, in our example, we have a tangent line and a secant line that intersect, and they form this intercepted arc. So if we wanted to find the measurement of ABC, we take 1/2 of our intercepted arc here. For example 2, we want to find the measurement of ABC if the measure of AB is 102 degrees. So we know our equation is that the measurement of the angle formed is 1/2 the measurement of the outer arc. And our outer arc is this part right here, but we don't know it. So in order to find this arc right here, we take 360 degrees, the entire measurement of the circle, minus this part over here, the 102. So we now know that our measurement of arc ADB is 258 degrees. And now we just plug it into our equation. The measurement of ABC is 1/2 ADCB, which is 1/2 258, which is 129 degrees. Theorem 3. If two secants, a secant and a tangent, or two tangents intersect in the exterior of the circle, then the measure of the angle formed is 1/2 the positive difference of measures of the intersected arcs. So here in our examples, so you can see that the angles are outside of the circle. So you take 1/2 of the positive difference of the intercepted arcs. So in our two secants, we take 1/2 of this arc right here and minus this arc right here. And again over here we take our upper arc minus our lower arc. Our last example, we want to find x. We know that our equation is the measurement of the outer angle is 1/2 the measurement of the outer arc minus the measurement of the inner arc. So in this case, it would be the measurement of angle y is equal to 1/2 the arc WV minus the measurement of the arc of BZ. First, so we know that WRV right here is a semicircle because of the line segment WV is the diameter. Therefore, the measurement of arc WRV is 180 degrees. So we now have all of our numbers to plug in. So we take the measurement of y is 45 degrees is equal to 1/2 the outer arc, which is 180, minus this inner arc, which is 10x. So we times by 2 to get 90 equals 180 minus 10x. And then we subtract 180 from both sides and divide by -10. And we get that our x is 9. I just want you all to remember, as you can see in the last examples, the variables can change depending on how the circle is labeled. You must understand how the equations were found using the labels on the given circles. So know that if you have an outside angle, you want to do the upper arc minus the lower arc.